Greetings, everyone. So, welcome back to my live channel. We'll be talking about inequalities in this session. Right? So, one of the things about inequalities is that there are ways that we can actually solve them. There are just some unique things that we need to look at. Also, in this lesson, I will definitely be touching, working with quadratic equations and solving an inequality equation with with our signs. All right. So, if you look right here, is that we are looking at these inequalities for this list. So we have our inequalities sign. So these are your signs, right? And in looking at them, we need to understand them before we get any further into this lesson. So I just want to even use a number line, and we will be using number lines to explain as we go along, right? So let us talk about where a condition applies where x is greater than 5. And when you hear such a statement, it's as if there's literally no end to the value of x. So we're going to be looking at all of that as well, just to how to interpret um, your signs. So we look here, and I'm going to just put like maybe your 0 right here. Well, let me put the 0 down here, and maybe 1, 2, 3, 4, 5, 6, 7. All right, so using that number line. Now, when we have a condition that says x is greater than 5, when we just have the greater than sign, we will just put an open circle here. Now, I don't really want to rush into this. I just want to take the time out as well to explain our signs. Is that how do I know which sign is greater than and which sign is less than? Now, if we look here, is that this could be interpreted as both ways. We could say that x is greater than 5, and if x is greater than 5, obviously 5 is less than x. But what I used to note which side is the greater than sign to say which part is greater. If I'm reading from left to right, I would look here. So I normally tell myself that here we have 2 points, 1 and 2. So these are 2 points. So if this is 2 points, and if I look right here, we have a vertex of just 1 right here. So I would say that this side, the part where the elbow meets there, where the elbow is formed right here, I think of any number that is on that side to be the less than sign. So you can actually use that to tell you which side is greater than the other. So I know that we've been talking about the less than or greater than sign, but the fact is any sign can be the less than or greater than sign depending on where you're reading it from. So if I'm reading from left to right, this would be my greater than sign. And if I'm reading from right to left, I'm saying 5 is less than x. So that's something basic that I just want to point out. Now, in representing these on number lines, to represent all of these inequality symbols, is that we actually use an open circle for the ones that has no that has no line under it. So I need to also explain to you the difference with the expression as the with the inequality with the line under it. Now, an inequality with a line under it is simply telling me that the value of x can equal 5 or x is greater than 5. So x could equal 5, 6, 7, 8. It could equal all the way up to infinity, right? Here again, if we see the x, when we see the x without when we see the inequality sign without the line saying that x is also equal to 5, it is saying, when we see it like this, without nothing under here, it is actually saying that x is actually less than 5. So x could actually equal to any number that is less than 5. So it could be 4, 3, 2, 1, could even be 0. Right? So x could be any number that is less than 5. Right? If we're looking at x is less than or equal to 5, here. So we would have x is less than or equal to 5. We're saying that x could equal 5, or x again, this value right here could come over here, and we have x, this could also equal to 4, 3, 2, 1. The idea of inequalities is to find the range of values of x. So x could be anywhere as long as it is less than 5. Here x could equal 5, or it could, or less than 5. So that is really what these terms are really saying. So we need to understand these things. And this is why I'm going to actually use the number line to explain it. So x is greater than or equal to 5. Right? So if we look here, if we have that, we are saying that x is either equal to 5 or x is greater than 5. So x could either be 5 or 6, 7, 8. Over here now, we would actually have x being greater than 5, meaning that x could either equal 6, 7, 8, but the bottom line is that x is not equal to 5. So those are just some basic things to understand about our inequalities. All right, so with that being cleared up, I also want to explain my line, my number line, right? So looking at my number line right here is that I use an open circle to use for the ones that have no equal sign under the no underline under the inequality, meaning that, so this one where we have this greater than sign, there's no line under it. So for those ones, we use an open circle. So here we see it again, we use an open circle. But for this one, we use a closed circle to tell us that x also equals 5. So we use a closed circle whenever x is also 5. Here again, we see it here, so we just use a closed circle to represent it on the number line. So here, looking at this one, we are saying that x is greater than 5. So any number above 5 is fine. So all the way up to infinity would actually be my result. All the way up to infinity. Right? So x doesn't have any end. Right? So that's just looking at the first one right here. Now looking at this one right here, what is my number line saying? So I'm just going to draw my number line. I'm going to start at 0. For here, I'm just going to start at 5, 6, 7, 8. And as I said before, with the ones that once it is x is equal to 5, we close the circle and then we show where it is going. So again, this is all the way to infinity. Right? Here again, now we draw our number line. We have a 0 mark right here. And we could have, all right, for this one, I'm going to start at 5 here because this is saying x is less than and 5, so I'm just going to come backwards. And of course, we could go into our negatives as well for this one. So here we put, where we say x is less than 5, we put over 5 an open circle, and we indicate that we're going to this direction. And again, this can bring us all the way up to infinity. So that is how we express that on a number line, right? Here, I'm sure you get the understanding by now that it's really the same thing. So x is less than, we would just have the number line again at 5 here, 4, 3, 2, 1, 0, and the negative 1, and we use a closed circle, and we indicate all the way up to infinity. So that is really how we actually do get our number line. But it really gets a little bit more complex when you start to solve inequalities when you're actually given an equation. So, well, not an equation, but when you're working with other terms, right? So, just to say that inequalities don't form equations. They're actually, an equation means that there's an equal sign. An inequality is not an equal sign. It's an inequality. Right? So, I'm just going to look at some simple examples for us, right? So, let us say that I have, for example, 3 is less than z. which is less than 6. Now let us look at that. Now, if we were to look at this, how would I represent this on the number line? Well, it is very simple. We just draw a line here, right? We would actually have values that, well, we could actually start at 3, right? 2, 3, 4, 5, and we also have 6. Let's go up to 7 and 8, right? We know that this is all the way to infinity, even down to the negatives and infinity. All right, so let's look at this, right? So our inequality right here, if we say that we're actually at a 3, we're going to use an open circle to represent these inequalities, right? So this one is at 3, and we're also looking at 6 right here. Now this is saying that our z is, if you're reading, remember where the 2 points is pointing. Wherever the 2, it doesn't matter if this is a less than sign, or you might say that it's a less than sign. The fact is, any side that the 2 points opens up, it means that it is greater. So z is greater than 3. So we could indicate that z is greater than 3. So anywhere above 3 would be 4, 5, 6, 7, 8, all the way up to infinity, right? Now 6, where we have the 6 now, this 6, we're saying that z is actually less than 6. So here we have the vertex right here. So z is less than 6. So any value that is less than 6 which would actually be all the way back to 3, coming back this way. So the idea is that anywhere between 3 and 6 is z. So z is any value between 3 and 6. So z is either 4 or 5. So either z equals 4 or z could equal 5. That's what we're saying, right? But there's something that I want to say. Say, for example, you're giving a questions to say that z is a factor of 24. Now, give the value of z wherein that might be true. Now, if we look at the values that we receive here, what we found here is that z could be 5 or 4. 5 is not a factor of 25. Sorry, of 24. 5 is not a factor of 24, but rather the 4 is a factor of 24. So therefore, if you receive a question where you need to find the value of z, wherein z is a factor of 24, it would just be 1. That would be 4. So that is actually a question that you might see as it relates to inequalities. All right, moving on to the next part of this. All right, so we want to look at like range of values as it relates to inequalities. So let us look at this one, for example. So we have 7 minus 4x, which is greater than 15. All right, so we're just going to look at that. So before I do that one in particular, there's one that I want to look at before I do, because there's something about that one that I just wrote that I want to look at. So find the range of values of v when we have 5 minus v is less than or equal to 2v minus 1. So let us look at this one now, right? So the question is that we're going to find the range of values for v. So we want to find, and I just want to reiterate the point that I'm saying with inequalities. Inequalities actually give you to find the range of values of a variable, we can say a variable, right? So we know the range of values of that value, of that variable. So how do we go about solving this? Well, the first thing that we can do to solve this is just simply that we can group our terms. And when we're working with inequalities, we can do the workout as similarly as when we have an equal sign. So let's look at this now. So we have 5. We can group the 5. We can group the 5 and the negative 1. Right? So we have 5. This now is going to come over as we already know how to do these mathematical problems. And I also have videos how to actually do these forms of workout. Right? So 5 plus 1. So we're actually going to remove the v as well. So remove it by addition. So here we're actually adding it. Right? So I'm sure you'll understand what we got here. Just by that. So check out my other math videos if you want to learn more about grouping terms and removing terms from one side of an equation and so forth. Right? So now we have this. We group our terms. So we can actually have this now as 6 is less than or equal to 2v plus v equals 3v. As I said before, is that we can actually solve for v the same way or we actually do it when we're working with an equation. So here now we could say that 6 is less than or equal to v. And what's going to happen with the 3 is that we're dividing the 3 to remove it from here. And if we divide it here, we also have to divide it here. So in cancelling out, we would actually have 2 being left. So 2 is less than or equal to v. All right? So so this is what we have right now. 2 is less than or equal to v. So in that inequality, we can actually look at it. Let us determine our range of values for wherein 2 is less than or equal to v. Right? So just looking at range of values now. So if we were to draw our number line, so drawing our number line, just looking at it from this angle, so we said that 2 is less than or equal to v, right? So that means that v is greater than or equal to 2. So we can start with the 2 right here. We have 3, 4, 5, 6, 7, and we can just stop at 8. So we would actually, because we have the equality there, we can shade this right there as what was explained before. And we say that v is actually greater. So all the way up to infinity, right there. That's what 2. That is exactly what 2 is less than or equal to v is actually telling us. Now, one of the things that it would be nice to check our answers. When checking our answers, the question we had our question before was that 5 minus v is less than or equal to 2v minus 1. So the idea is that if 2 is greater than or equal to, if v is greater than or equal to 2, we can check that to see what we will have if this would actually result to be true, right? So just going to erase this, and we're going to check how some values. So we're going to start with this one right here. So 5 minus 2 is less than or equal to 2 in bracket 2 minus 1. So this would be 3 is less than or equal to 2 2s is 4, and 4 minus 1 gives us 3. So we see we're at this point. Our solution works out to be that 3 is actually equal to 3 in the solution, right? Now in another solution, let us see if we were to put. Well, let us try use another number. Let us use 5. So if we had 5 for the v, what would we get? So 5 minus 5 is going to be 0, right? Let us check if 0 is less than or equal equal to 2v minus 1, which is 10 minus 1. 10 minus 1 is going to give me 9. So we can see that 0 is less than or equal to 9. So this also results to true, because this is, we can see that 0 is less than 9. And that's the idea of testing. That is how we actually test, if to see if this range of values, if it is true. So we can see that it is true that x is therefore greater than or equal to 2. So that is how we work that one out. All right, we're going to move on to something a little bit interesting from here. Is that we're going to look at something, and it is something to be noted carefully when you're working out inequalities. All right, so I have this question that I just put on the board. 7 minus 4x is greater than 50. So that's what I have right there. So we're going to look at this one. And I want you to pay key attention to every step of the way. So we want to solve for x, right? I know that this is just saying greater than 50. So in solving for x, the idea is that we need to remove this positive 7 by subtracting it, as you will learn when you're solving an equation. So this is going to be left with 4x is greater than 15 minus 7 gives me 8. Now, if I were to divide this now by negative 4, I also have to divide this also by negative 4. So the negatives 4 is going to be cancelled out, and I'm left with x is greater than, so, and this would be 4 into 4 is 1, 4 into negative 4 into 8 is going to give me negative 2. So that would be negative 2. Now, we are going to test this equation right here, just to make it be clear. We're going to test this equation right here to see if this is true. So it's always excellent to test your equations to see if they are true, right? So we're going to look at testing this one as well. So we're going to rewrite 7 minus 4x. And before I even write it out there, it's excellent to establish the number line. So we're going to have our number line. Now in my number line, we said that x is greater than negative 2, so we're going to start with the negative 2. In fact, I'm going to start with my negative 2 here. 1, I'm going to put 0 here, and wait, why did I put 0 here? Should be negative 3 rather, negative 4, negative 5, negative 1, 0, 1, 2, it's continuing 3, 4. Right? So we're going to work with that. And we're going to now put this data, this information, we're going to reflect it on the number line. So let us do that. So where we have x is greater than negative 2, we're going to start at negative 2. And remember now we're going to use an open-ended circle. Right? So we're going to leave it open circle. So this negative 2 is open here. Right? And we're saying that x is greater than negative 2. So negative 1 is greater than negative 2, 0 is greater than negative 2, 4 is greater than negative 2. So we're going to put that in our information up here, and we're going to see if that is going to be true. So let's erase all the blue marker there. Let us put that up here and see if we're going to get that to be true. So 7 minus 4, let's choose a value. So if x is greater than negative 2, let's choose a value that is greater than negative 2. We can start with 0, 0. And we're going to see if this is going to be true. So 7 minus 4 times 0 is greater than 15. Understanding our laws of pendulums, we know that we have to do multiplications first, so that's going to be 0. We have minus 7 here. And when we look, we see that 7 minus 0 is going to be 7. And when we look, we're looking at something very interesting because this is saying that 7 is greater than 15. And is that true? No, that is actually false. Maybe I should not have used the 0. Let us try use something else. So we can use something else. Let us try and use maybe 3. Right? So we could, let us say we're going to use 3. Alright, so 7 minus 4 threes is 12 is greater than 15. 7 minus 12 is going to actually give me negative 5. And we're saying that negative 5 gives us 15. So we see there also that that 2 equals false. So where did we go wrong? Now, in terms of the mathematics about behind all that we did just now, everything was fine. It's just that there's just one small thing that we did not do. So, or let's say it's a little rule that was ignored. Right? So we're going to do it, look at it again. So when we're doing our calculations, we actually remove this 7 and put it over here. So we're going to just do that again, which would give us negative 7. Now we have negative 4x is greater than 15 minus 7 gives us 8. Now, here is the rule that we actually ignore, is that whenever we're actually dividing both sides by a negative, whenever we're dividing both sides by a negative, the sign, which is like a greater than sign in this case, is going to change from, we're going to have a flip to the side. So the sign now must change from a greater than, from saying x is greater than, to say that x is less than negative 2. So if x is less than negative 2, we know that negative 3 is less than negative 2. And we know that negative 5 is also less than negative 2. So everything that's down here is less than negative 2. And now we're going to check that to see if that information is correct. So let us go ahead now and check. So if we had 7 and we can choose any number now to represent for x. Let's say that x is negative 4. And we say that that is greater than 15. Now that when we are checking, we keep everything as it was, right? Even the sign. So we know that 7 minus 4 times 4 is 16. And since the negative 4 is actually 4 times negative 4, it's going to give me negative 16. Right? The bottom line is that that's going to give me a positive 16. And we are saying that that is greater than 15. So 7 plus 16 is going to give me 23. And 23 is greater than 15. So we see that now evaluates true. So that's something to bear in mind, that whenever you're going to divide by a negative, divide both sides by a negative, you should flip the sign. The sign actually turns around. Alright, let's now talk about quadratics. Right? So we're now going to look at quadratic inequalities. So we're going to look at quadratics. So this is where we are now, looking at quadratics. Alright, so let's look at a 2x squared minus 9x minus 5 is less than 0. So let us look at that one. Alright, so this one now is very simple. And the idea is that we should go ahead and just solve this like a regular trinomial. We can just go ahead and do that. So we know 2 times negative 5 is going to give me negative 10. Listing out the factors of 10, my two numbers are going to be negative 10x plus x minus 5. And I'm just going to have my equal sign, which equals to 0. So I'm just working out like a regular quadratic equation, right? So in having that now, is that I'm now going to actually factorize and simplify this entire equation. So I'm going to factor the 2x here. Zero. And I'm also going to solve for x. 0. This is going to be x minus 5. 0. If you want to learn about factorization, please check my other videos where that will be explained in depth, right? But for now, we're really going through inequalities. So here we can see that x actually is going to equal to negative. Just checking something here. So right, so that's going to be negative. So that's negative. Right. So what happens when I bring this over here is going to be a negative 1. So that's negative 1, and this 2 is going to be over 2. So we would have x equals negative a half. Here now, what would we have? We would literally be having x minus 5, right? So this one would be x. This would be a positive 5, so it's going to be a positive 5 here. So x equals 5, right? So those are the two possible answers for 5 for x. All right. So we have that. In having that and understanding inequalities is that we know we must have this. I'm going to represent this on a number line. So having this on a number line. So this information, I'm just going to put it on a number line where I'm going to put this as, so 0 is going to be here. A half, well, negative a half is going to be right here. So negative half is going to be right here. And this would be 1, 2, 3, 4, 5. Right? Just negative now, here we can have, well, let me also include some other values down here. Just put that here. So we're saying that we're in this equation actually evaluates to is less than 0. Now, if we look here, we could actually have our open-ended circle there, and we also put it at our 5 right here. Right? So we have open circles right there. Now we need to find the range of value for x. So how do we actually look at that? So I put it over this here, should be over the negative. Alright. So looking at this now, the range of values for x. So, I'm actually kind of trying to squeeze certain things in right now. So we have 2x plus 1 bracket, and we have x minus 5, I believe that was it, that we had. Right? So we're gonna actually put in these values. So let us say if x is negative a half, right? If x is negative a half, we're gonna have 2 bracket negative 1 over 2 close bracket plus 1. So this is going to be cancelled out. So we have negative 1 plus 1, right, in one bracket. And here now we have negative a half minus 5. Irrespective of what this equals, the fact that negative 1 plus 1, so we have negative 1 plus 1, that equals 0. Now, we have to see where I believe it should be less than or equal to 0, is it? Right. So here now, no, question didn't have less than 0. The question didn't have the equal 0. It just had less than 0. So if we were to look at here, right, using the half, the negative a half, right, is that 0, this value right here, if this equals 0, 0 times this right here, this bracket, whatsoever is here, it equals 0. If it multiplies this bracket, it means therefore that the equation would not be that 0 is not less than 0. So that would not be true. Right? I almost think that that question had an equal sign there when I was writing it. But anyways, so the 0 would be, so that now would be saying that if x is it was to be a half, the value of this would actually be 0, right? Now, if we were to look again now and say now if we're gonna choose to see if x was less than negative a half, what will that give us? So let us check that again another time. So we're going to look at if x was 1, for example. And remember, this is actually an open circle, right? And an open circle tells me that, you know, if the range of values is down here, it's actually, this half wouldn't be included. So in working this out, -1, I'm not sure what I'm trying to explain there. -1. So 2 times -1, 2 times -1 is going to give me -2 and +1. So this is actually going to give me, -1. Now -1, and if this now is -1, -1 minus 5, -1 minus 5 is going to give me -6. So here, -1 multiplied by -6. So this value right here is -1, and this value right here is -6. And we're actually multiplying the two. So -1 multiplied by -6 is going to give me +6. So we can see then that if the value for x is less than, if it was less than a half, then we can see then that this value up here, this would be saying 6 is less than 0, given that we choose that x is actually -1. So that we cannot say that the range of value of x is actually less than -1. So we can't say that. So what we need to find out is that, can we say that the range of value for x is greater than -1/2? So we can actually try that with 0. We could actually use any one of these numbers that's actually between. So we could use 0, we could use 1. Let's use 1. So if x is 1, we are saying 2 times 1. 2 times 1 is 2, and 2 plus 1 gives us 3, right? So this is going to give me 3. So this equation right here will give us 3 if x is 1. Look at this now. If x is 1 again, we're saying x 1 minus 5. 1 minus 5 is going to give me -4. Right? So this is a -4 right here. And remember, as I said, we're multiplying them. So the idea is that 3 multiplied by -4 is going to give me -12. And here we can see that -12 actually is less than 0. So the range of value we could say is that x is greater than -1/2. So we will look now to start to go that direction. So we start to think of going that direction. So x is greater than -1/2, and this would actually evaluate the true. So any number that is greater than -1/2 is going to make this equation be true. So my range of value for x for here would be that x is greater than -1/2. Now we have to also figure the range of value for here. So what is my range of value? What is the range of value? What are my numbers coming from here now? So just gonna have my x there. So for example, we also have 6 and 7, 8. If we were to choose that x is 7, so if we say x is 7, we're saying 2 times 7 is 14 plus 1. So this would actually be 15, right? And here now we say that 7 minus 5, that would actually be equal to 2. 15 times 2 is going to give me 30. If we check this and see now, if we see that 30 is there, we can't say 30 is less than 0. So what is that telling me? That is telling me that the range of values from this direction is that we cannot say that x is greater. We can't say that x is greater than 5. But can we say that x is less than 5? Let's look at it. Let's look at it. So just going to put this over here. 1, x minus 5. All right, so we're still finding the complete range of value, right? So look here now. We have an open circle right here. And we want to see if these values right here, all of these values, we're going to test the other remaining portion of these values, right? So if x was 4, well, we actually tested 4. We did test 4. And we know that 4 actually made the equation true. Say if we were to test even 3, if we were to test x, if that x is 3 plus 1, this would actually 6 plus 1 is going to give me 7. And if this would be 3, so 3 minus 5 would actually give me negative 2, right? So 7 multiplied by negative 2 is going to give me negative 14. So is negative 14 less than 0? And the answer is yes. So we can say then that the range of value of x is that x is, watch carefully now, is that x, we can say the range of value for x is that negative a half is actually less than x, but x is less than 5. So x is not greater than 5, and negative a half. So x is not greater than 5, but x is greater than negative a half. So any number from 0 to 4, would actually let this equation evaluate to true. So that's basically what I'm trying to explain here, right? So that is what I wanted to get. So this would be my range of values. So this would be the range of values. So any value between this is actually going to make this equation be true. Let us look at one final one. So we have like x, for example, minus, well, x squared, because we're still working with quadratics, minus 6 is less than or equal to 0. Let's look at that one. So we need to find the range of value for x, where if I plug in that value into x is going to, the equation, or the value of the solution is going to evaluate to true. So let's look at this now. So we're going to use the trinomial expression way of solving this. So as we know, a times c, so that is a times c. You have to learn factorization to know what I'm working on here. Going to give me negative 6. And the two numbers that I'm going to use is negative 3x plus 2x minus 6. And I'm going to use equal 0 for now. Right? So in solving this, I'm going to take out that. This is going to be taking out positive 2x minus 3, 0. So now we can actually group them as x plus 2 in one bracket and x minus 3. So you have to know how to factorize trinomials to get this. This is just basic trinomial exercise going on here. So now we are at the part where we are getting closer to our inequalities. So here we have x plus 2 is equal to 0, x plus minus 3 is equal to 0. Right? So this is going to give me that x equals negative 2 and x equals positive 3. So we're just going to have 3, right? So there are two values of x, negative 2 and negative and positive 3. So just erase all of that we have here. So drawing our number line now, we're going to look at our number line. So we now have negative 2 here, and we're going to have, I'm just going to put 3 right here. You know what is between them. 0 is always in the middle. Right? So we know that we have negative 3, and we know what is also here. And that we have like 4 and 5 here. Right? So we need to test our equation. It's funny enough, I just erased everything and I needed to go back there. And what did I have just now? Alright, so I had just a moment. I took out okay, I had x minus 3 and x plus 1. Can actually look at this and figure it out easily. So that's actually going to be x plus 2. That's what I had, and x minus 3. So that's what I had. And we're going to put our inequality sign now. We're saying that we're going to test if we're going to get this expression to be less than or equal to 0. So the fact that it has the equal sign, we're going to start at. It means that 2 is included in it. So if the fact that we actually got x to equal to 2, if x is negative 2, it means that the equation is going to be true. So we don't have to test negative 2, and we also don't have to test positive 3, because if you put negative 2 for x right here, this is going to evaluate to 0. So all of this equation is going to equal to 0. If we put 3 here in x, 0, this 3 right, this, if the x right here is 3, 3 minus 3 is going to be 0. And 0 times this equation is going to give me 0. So it's actually going to evaluate to true. But what we want to do is to find the range of values for x. So in finding the range of values for x, we have to look at it at this way. All right, so x plus 2 times x minus 3 is less than or equal to 0. So we're finding the range of values. All right, so we're going to test. We're going to be testing now. So we're at negative 3. If x was negative 3, and we say that negative 3 plus 2, that's going to give me a negative. It's going to give me a negative result, right? And if we have, again, negative 2 here, we're also going to have a negative result. A negative times a negative, well, in fact, we're actually going to get negative 6. And a negative times a negative is actually going to give me a positive. So it's going to be a positive 6. So 6 is not less than or equal to 0. So we know we can't go this direction, because any number from negative 3 to up, negative 3 up, is going to give me, is going to result in a false. So this is going to be false, because we see that 6 is not less than or equal to 0. So this equation cannot equal to 6, because it's not less than or equal, or less than or equal to 0. But if we were to choose a number that's between, we could choose 0. If x is 0, so this is between now. If x is 0, and we say 0 plus 2, that's actually going to be 2, right? And we know that we're actually multiplying, right? So we're actually multiplying, and we have as I said, x is 0, so that 0 minus 3, that's going to give me negative 3. 2 multiplied by a negative 3 is going to give me a negative answer, right? So here we have it. We have negative 6, and is negative 6 less than or equal to 0? Yes, negative 6 is actually less than 0. So if that is so, we know that this is true. So any number between negative 2 and 3, we can safely say then is going to let the equation evaluate to true. So we can also test these numbers as well. 4, if we can try putting 4 in between. We can try putting 4 in between. So let us put 4 in between, right? So 4. So 4 plus 2, that's going to give me 6, right? This also is going to be 4 minus 3. So that's actually going to give me 1. 6 times 1 is going to give me 6 times 1 is going to give me a positive 6. And now we know that this is not true. So 6 is not less than or greater, less than or equal to 0. So now any number here is also out of the equation. So the range of value of x would be from here to here. So how do I write that? How do I write that? So the range of values from here to here. So I write that as negative 2. So I put my negative 2 first, right? So negative 2 is less than or equal to x, and x is less than or equal to 3. You'll find that when you get the line between, when you get the range of values to between two endpoints, you get that these signs actually set in the same direction. All right? So that is really just a brief, I think it's brief, a brief explanation into this. There could be more that could actually come out of it, like maybe some questions, but I'll leave that for maybe another time. So you have to stay tuned to keep up with my videos for me to post more on this exercise if you would like to learn more. Also for factorization, please go ahead and look at my videos. I have videos on factorization. You can check those out as well. And just stay tuned and subscribe, like and subscribe, that you can actually receive the latest updates. Again, thank you very much for tuning in. Have yourself an excellent time. Thank you.